All right, let's take a look at the law of cosines. This is going to be particularly useful when we are given two sides and the included angle, or if you're given all three sides of a triangle. Okay. By the way, the side angle side version is what we did with the area in the previous section. When you're given just one corner of a triangle, the two sides, and that angle. We're going to be able to find the opposite side first using the law of cosines, and then the remaining angles. With the law of with the side, if you're given just three sides of a triangle, we'll again be able to use the law of cosines to find one angle, and then we can switch and use either the law of cosines or the law of sines to find the remaining angles. So let's take a look at the law of cosines. It starts with something that looks very reminiscent of the Pythagorean theorem. So I'm going to give you the first one, and there are three of them. So c squared equals a squared plus b squared. Again, there's your Pythagorean theorem, but the law of cosines continues with a -2, and then it's the product of the two sides that you squared already, so a and b, and then times the cosine of angle c, which is always going to be this angle across from the side that you're working with on the left. So for the b version, it would be b squared equals, and then it's the sum of the squares of the other two sides minus twice the product of those two sides times the cosine of the angle across from what you began with. So then it's a squared equals b squared plus c squared minus 2bc cosine of angle A. So this is particularly useful if we, again, given that side angle side piece, where you have A and B and then angle C, you just plug it all in on the right-hand side, take the square root to eliminate the squared, and you've got your side. Now the alternative form is if you have the side, 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 where you want to go ahead and find the angle. Now there's nothing to stop you from putting the three sides in, okay? We can put in side A, side B, side C, and then solve this formula for angle C. And by the way, we'd also put A and B here as well. But there is a direct formula, okay? And using this version right here, starting with angle C, it's going to be C equals, well, you'd have to get rid of the cosine in front of it, so there's your cosine inverse of, now to solve this equation, we would start by subtracting A squared and B squared, then you would divide by the negative 2AB. So what you end up getting, when you divide by that negative all the sign switches, you get A squared plus B squared minus C squared over 2AB. So the way that I remember is C is the cosine inverse of, and it's the other two sides, not side C. So it's A squared plus B squared, then we subtract C squared, and then we divide by 2AB. So B would be the cosine inverse of A squared plus C squared minus B squared over 2AC. And A would be the cosine inverse of B squared plus C squared minus A squared over 2BC. So what I want to do, finishing this first video, is just take a look at that first example. The second video will be the second example, just because it's a little more in depth and there's a couple things I want to talk about. And then I'll do one more video with the area of a triangle given the three sides. So let's take a look at example number 1. Find the remaining sides and angle of this triangle. So again, we're given this entire bottom left-hand corner. That's that side, angle, side, side, angle, side. So we're going to go ahead and we have to start by finding side A. So we're going to go A squared is equal to B squared plus C squared minus 2BC cosine of angle A. And I have no problem if you skip over this step and just write that A is equal to the square root of that whole thing. And I would suggest plugging all of this in as is into your calculator to avoid rounding errors and the such. So A comes out to B. So let's go ahead and do that. So we have the square root of 9 squared plus 12 squared minus 2 times 9 times 12 times the cosine of 25. And we get 5.41. Now, What we need to do from here is we need to find the angles. Now there is a star here, okay, an asterisk. When using, if you have a choice, when using the law of sines, always find the smallest angles first. This is because, and you'll see in just a minute, if we start off finding angle C, which by the way is the largest, A is the smallest side of 5.41, B is the middle side, C is the longest side, therefore C is the largest angle. In this case here, C comes out to be an obtuse angle. And when you use the law of sines to find an angle, so you use that sine inverse, it will never give you an angle larger than 90. It's always going to give you that angle between 0 and 90 degrees because sine is positive in quadrant 1 and quadrant 2. So if you sine inverse a positive ratio, it's going to give you the quadrant 1 acute version of the angle. You would have to know that you want the obtuse version. So the way to avoid that whole mistake is just let's find angle B, the next smallest angle. So I'm going to go A over sine A. So I'm going to go 5.41 over the sine of 25 equals, we're going to go B over sine B. Cross multiply. Divide both sides by 5.41. And then take the sine inverse. So B comes out to B, so let's do that. So the sine inverse of 9 sine of 25 divided by 5.41 is 44.7 degrees. And now to find angle C, we're just going to go 180, take away angle A plus angle B, and we get 110.3 degrees. See, that will never be an answer. No matter what you do, sine inverse of anything will never be 110.3. What you would have gotten was you would have gotten 69.6 had you done it out that way. And you would have had to have known that you need to go ahead and find the supplement of that. So to avoid that, like I said, when using the law of sines, always find the smallest angles first. All right, we'll continue with example 2 in the next video.